Hello students, welcome to this lecture, one Conic Sections. So in this lecture, we will discuss NCERT section 10.4.2 and we will discuss example 5 to 8. So the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. So if you are the owner and have any concerns or issues, then please contact us at sathee@iitk.ac.in and we shall remove the content immediately. So please note that parts of the content may have been generated using generative AI, which is experimental. So first we will discuss about lattice rectum. Okay, so we will discuss first lattice rectum. Then we will discuss example 5 to 8. So let's get started. So first, here we will discuss definition of lattice rectum. So what is the definition of lattice rectum? So we have studied in our previous lecture about focal chord. Okay, so focal chord is a chord which is passing through the focus point. Okay, and lattice rectum is one type of focal chord which passes through the focus and perpendicular to the axis of the parabola. Okay, so the chord through the focus which is perpendicular to the axis of parabola is called lattice rectum. Clear? So this is the definition of lattice rectum. So look at this figure. So here in figure 10.17 we have here this line. Okay, this line is basically lattice rectum. So this line is a chord which is passing through the focus, okay, and perpendicular to the axis of parabola. Okay, so this is our lattice rectum. So I hope it is clear to all of you. Okay, so what is lattice rectum that we have discussed here? So now let us move to the next slide. So now we will derive length of lattice rectum. Okay, so now we will know how to find length of lattice rectum. Okay, so let's see how to derive length of lattice rectum. So this is the figure. Here in this figure you can see this is our lattice rectum. Okay, so AB is basically length of lattice rectum. Okay, so AB is the length of lattice rectum. And how can we find length of lattice rectum? So for that we will derive how to find length of lattice rectum. Okay, which formula we can use to find length of lattice rectum, that we will discuss. So in step 1, first consider the parabola y square equal to 4ax. Okay, so consider here y square equal to 4ax, and what is the focus of this parabola? So the focus for this parabola is f. Okay, here this point f physically coordinates of f are a comma 0. So the focus is f a comma 0. And in step 2, here you can see the lattice rectum. The lattice rectum is a vertical line passing through focus f. Okay, so its equation is x equal to a. So the lattice rectum is a vertical line and passing through the focus a comma 0. So the equation of the lattice rectum is x equal to a. And in step 3, here you can see, to find the endpoints of the lattice rectum, here we have to substitute x equal to a into the equation y square equal to 4ax. Okay, so here just substitute x equal to a into the equation y square equal to 4ax. Okay, and then you will get y square, this is equal to 4 times a, this is equal to 4a square. Okay, so you will obtain here this equation y square equal to 4a square by substituting x equal to a into the equation y square equal to 4ax. Okay, so now we have to solve for y. So in step 4 we will solve for y, and here if we take square root, okay, in both side, then you will get y equal to plus minus square root of 4a square. Okay, and this is equal to basically plus minus 2a. So y, this is equal to plus minus 2a. And then in step 5, here now you can easily find endpoints of the lattice rectum. Okay, so in the figure you can see the endpoints of the lattice rectum are basically a and b. Okay, and here we find the value of y equal to plus minus 2a for x equal to a. Okay, so when x equal to a, then y equal to plus minus a. So coordinates of the point a are a comma 2a. Okay, and the coordinates of the point b are a comma minus 2a. Clear? So the end points of the lattice rectum are a comma 2a and b a comma minus 2a. Clear? So I hope it is clear to all of you. Now here we obtain the end points of the lattice rectum. Okay, here we obtain the coordinates of the point a and the coordinates of the point b. And now what we will do? So now the length of lattice rectum is the distance between the point A and B. Okay, so length of lattice rectum is nothing but the distance between the point A and B. So easily you can now find distance between the point A and B. So length of AV, this is equal to modulus value of 2A minus of minus 2A. Okay, and this is equal to modulus of 4 times A. So length of AV is modulus of 4 times A, and since here A is always positive, okay, this is nothing but equal to 4 times A. So therefore length of lattice rectum, okay, length of lattice rectum AB is 4 times A. Okay, so this is the formula to find length of lattice rectum of a parabola y square equal to 4ax. Okay, and similarly you can find lattice rectum for another form of the parabola, like y square equal to minus 4ax, x square equal to 4 times a times y, x square equal to minus 4ay. Okay, so for all the cases, here the length of lattice rectum AB is basically 4 times a. Okay, so note here the length 4 times a is the coefficient of the linear term in the standard equation. Okay, so you can observe here the standard equation of the parabola is y square equal to 4 times ax. Okay, and 4 times a is basically coefficient of linear term. Okay, so the length 4 times a is the coefficient of linear term in the standard equation. Okay, so length of lattice rectum of a parabola is basically the coefficient of the linear term. Okay, that is equal to 4 times a. Now we will discuss some standard forms of parabolas, okay, and their vertex, focus, directories, equation of directories, axis of parabola, and direction of opening. Okay, so first visualize the figure, okay, and then from that figure find the vertex of the parabola, focus of the parabola, and equation of directories. Then find axis of parabola, and then find in which direction the parabola is opening. Okay, so look at first one. So here in first figure you can see the equation of the standard equation of parabola is y square equal to 4 times ax. Okay, so for this parabola, here you can see the vertex at origin 0 comma 0. Okay, and the focus point is a comma 0. Okay, and the equation of the directories is x equal to minus a, and axis of parabola is x axis. Okay, and equation of x axis is basically y equal to 0. And here you can see direction of opening. So the parabola, this parabola opens to right. Okay, so from this figure we obtain these informations. Okay, equation of parabola, vertex, focus, direct equation of directories, axis of parabola, direction of opening. Okay, similarly you can find vertex, focus, equation of directories, axis of parabola, and direction of opening of standard equation of parabola y square equal to minus 4ay for 4ax. Okay, so for y square equal to minus 4ax, vertex at origin 0 comma 0, focus at minus a comma 0, and equation of directories is x equal to a. Okay, and axis of parabola is x-axis. Okay, axis of parabola is x-axis, that is equation of the x-axis is y equal to 0, so axis of parabola is y equal to 0. Okay, and this parabola opens to left direction. Okay, and now see third standard equation of parabola, that is x square equal to 4 times a y. Okay, so for that standard equation of parabola, you can see here this figure. Okay, this figure is basically for x square equal to 4 times ay. Okay, here you can see the vertex of this parabola at origin 0 comma 0, and the focus of this parabola is at f 0 comma a. Okay, and axis of parabola is y-axis, that is x equal to 0. Okay, and here you can see the equation of directories is y equal to minus a. Clear? And here you can see this parabola. Okay, this parabola opens to upwards. This parabola opens to upwards. So when a parabola opens to upwards, when in standard equation of parabola x square equal to 4 times ay, the coefficient of y is positive. Okay, then in that case the parabola opens to upwards. Okay, so this parabola opens to upwards. Clear? And now look at this equation, x square equal to minus 4ay. So for this equation, the diagram is basically this one. So this one is the diagram for x square equal to minus 4ay. So what is the vertex for this parabola? So vertex at origin 0 comma 0. Okay, and the focus point is 0 comma minus a, and equation of directories is a y equal to a. Okay, and axis of parabola is y-axis, that is x equal to 0. Okay, and this parabola opens downwards. Okay, opens downwards. So when coefficient of y is negative, that case the parabola opens to downwards. Okay, so try to remember this point. When for y square to minus 4x, when a coefficient of x is positive, that case opens to right. When a coefficient of x is negative, that case opens to left. Okay, when coefficient of y is positive, that case opens upwards, and when coefficient of y is negative, that case the parabola opens downwards. Okay, and we have studied here vertex, focus, directories, axis of parabola, and direction of opening of the 4 standard forms of parabolas. Okay, clear? So here a is always taken as a positive constant. Okay, so always take a as a positive constant. Now we will discuss NCERT section 10.4.2 example 5. Okay, so first read the example very carefully. Okay, and then answer the example. So we have to find the coordinates of the focus, axis, the axis of parabola, and the equation of the directories and lattice rectum of the parabola y square equal to 8x. Okay, so we have given the equation of parabola is y square equal to 8x, and then we have to find the coordinates of the focus, axis and then we have to find the equation of directrix and lattice rectum. Okay, length of lattice rectum. Clear? So first of all, try it yourself. So you have 1 minute to try to solve this example, and after that we will solve this example. Okay students, now we will solve this example. So the given equation of parabola is y square equal to 8x. Okay, and this equation is of type y square equal to 4 times ax. So the axis of symmetry is along the x-axis. Okay, so since the given equation y square equal to 8x is of type y square equal to 4 times ax, so the axis of symmetry for this parabola is along the x-axis. And here the coefficient of x is always positive, so the parabola opens to the right. And now comparing the given equation y square equal to 8x with y square equal to 4 times ax, then you will get the value of a. So we get 4 times a equal to 8, and it implies a equal to 2. If the axis of symmetry is along the x-axis, then focus is a comma 0. Okay, so here we have a equal to 2. So what will be the focus of the parabola? So thus the focus of the parabola is 2 comma 0. Okay, and the equation of directrix of the parabola is x equal to minus 2, and length of lattice rectum is basically coefficient of linear term. Okay, here we have coefficient of x is 8, so length of lattice rectum is 8. Clear? So here you can visualize in this figure the focus at 2 comma 0, okay, vertex at origin 0 comma 0, and the equation of directrix is x equal to minus 2, okay, and length of lattice rectum is 8. So I hope it is clear to all of you. So now let us move to the next example. So in this example, we have to find the equation of parabola with focus 2 comma 0 and directrix x equal to minus 2. Okay, so let's try to find the equation of parabola with focus 2 comma 0 and directrix x equal to minus 2. First of all, try it yourself. So you have 45 seconds to try to solve this example, and after that we will solve this example. Okay students, now we will solve this example. So given that the focus 2 comma 0, okay, and the equation of directrix is x equal to minus 2, so what can you guess? So focus lies on the x axis, Okay, since here we have the focus 2 comma 0, so any point of x is in the form a comma 0. Okay, so focus we have given 2 comma 0, so focus lies on the x axis. Okay, and it implies x axis is the axis of parabola, and we know that if focus lies on the x axis, then in which type of equation we will get? So then the equation of parabola is of the form either y square equal to 4 times a times x, okay, or y square equal to minus 4ax. Okay, so we may get either y square equal to 4 times x or y square equal to minus 4ax. And given directories is x equal to minus 2 and the focus is 2 comma 0. So among these two equation, which equation will be the equation of the parabola? Okay, so we know the equation of directories is x equal to minus a for y square equal to 4ax. Okay, so given that the equation of directories is x equal to minus 2, so it implies the value of a is 2 and the parabola is to be of the form y square equal to 4 times ax with the value of a is 2. Hence, the required equation of parabola is y square equal to 4 times 2 times x. This is equal to 8x. Okay, so y square equal to 8x is the required equation of parabola with focus 2 comma 0 and directories x equal to minus 2. Clear? So I hope it is clear to all of you. So now let us move to the next example. So in this example, we have to find the equation of the parabola with vertex at 0 comma 0 and focus at 0 comma 2. Okay, so we have given here vertex of the parabola 0 comma 0 and focus at 0 comma 2, and then we have to find the equation of the parabola. So students, first of all, try it yourself. So you have 40 seconds to try to solve this example, then after we will provide the solution. Okay students, now we will solve this example. So given that vertex is at 0 comma 0 and the focus is at 0 comma 2. So the focus 0 comma 2 lies one y-axis. So it implies y-axis is the axis of the parabola. Okay, and we know the focus on y-axis is 0 comma a and this is equal to 0 comma 2. Okay, so the focus one y-axis is 0 comma 2 here. So from here we will get the value of a is 2. Okay, so it implies a equal to 2. Therefore equation of the parabola is of the form x square equal to minus 4 times x square equal to 4ay. So thus we have x square equal to 4 times 2y, that is x square equal to 8y. Okay, so the equation of the parabola with vertex at 0 comma 0 and focus at 0 comma 2 is x square equal to 8y. Okay, so this is the required equation of the parabola. So I hope it is clear to all of you. So now let us move to the next example. So look at example 8. So in this example, we have to find the equation of the parabola which is symmetric about the y-axis and passes through the point 2 comma minus 3. So students, first of all, try it yourself. So you have 40 seconds to try to solve this example, and then after we will provide the solution. Okay students, now we will solve this example. So let's solve this example. So given that the parabola is symmetric about y-axis and has its vertex at the origin, okay, and then the equation of the parabola is of the form either x square equal to 4 times ay or x square equal to minus 4 times y ay, okay. So but the parabola passes through the point 2 comma minus 3, and 2 comma minus 3, this point lies in the fourth coordinate, okay. So what can we say? So from here we can conclude which type of parabola we will get. So thus the equation is of the form x square equal to minus 4 times ay, okay. So the equation of the parabola is of the form x square equal to minus 4 times ay. And since the parabola passes through the point 2 comma minus 3, so 2 comma minus 3, this point satisfy the equation x square equal to minus 4 ay. So it satisfies the equation x square equal to minus 4 ay. So just put here x equal to 2 and y equal to minus 3 in the equation x square equal to minus 4 ay, and then you will get the value of a. So after substituting x equal to 2 and y equal to minus 3, we will get this equation 2 square, this is equal to minus 4a times minus 3, okay. And from here you will get the value of a is 1 by 3, okay. So therefore a equal to 1 by 3. So therefore the equation of the parabola is x square equal to minus 4 times 1 by 3. Just substitute here a equal to 1 by 3 in equation x square equal to minus 4ay, and then you will get the equation of parabola is x square equal to minus 4 times 1 by 3, that is 3x square equal to minus 4 times y, okay. So this is the required equation of the parabola which is symmetric about the y-axis and passes through the point 2 comma minus 3. So I hope it is clear to all of you. Now we will discuss another example, okay. So in this example we have to find the coordinates of the focus and the axis of the parabola, and then we have to find the equation of the directrix, and then we have to find the length of lattice rectum, okay, for the parabola x square equal to minus 16y. So we have given the equation of parabola is x square equal to minus 16y, okay, and then we have to find focus, axis, equation of directrix, and length of lattice rectum. So students, first of all, try it yourself, try to solve this example, okay. So you have 40 seconds to try to solve this example, and after that we will provide the solution. Okay, students, now we will solve this example. So let's solve this example. So the given equation is x square equal to minus 16y. Okay, and this equation is of the form x square equal to minus 4 times ay. So just compare, okay, the given equation with the standard equation x square equal to minus 4ay. Then you will get the parabola x square equal to minus 4ay opening downwards. Why? Because you can see here the coefficient of y is negative. Okay, so this parabola is opening downwards. Now compare the given equation x square equal to minus 16y with the standard form x square equal to minus 4 times ay. Okay, then you will get the value of a. So therefore you will get this equation minus 4 times a equal to minus 16. Okay, and it implies a equal to 4. So the value of a is 4. So the focus of x square equal to minus 4ay is at 0 comma minus a. Okay, so now you can find focus of the given parabola x square equal to minus 16y. Okay, just put the value of a is 4. So here a is 4, then the focus of the parabola x square equal to minus 16y is 0 comma minus 4. Now find axis of parabola. So for the form x square equal to minus 4 times ay, what is the axis of parabola? So for the form x square equal to minus 4ay, the axis of symmetry is the y-axis, whose equation is x equal to 0. Okay, so the axis of parabola for the form x square equal to minus 4ay is y-axis, that is x equal to 0. And then find directories of the given parabola. Okay, so the equation of the directories for the form x square equal to minus 4ay is y equal to a. Okay, so now you can find the equation of directories of the given parabola x square equal to minus 16y. So here a is 4, so the equation of directories is y equal to 4. Okay, for the parabola x square equal to minus 16y. And now find length of lattice rectum. Okay, so the length of lattice rectum for the parabola x square equal to minus 16y is 4 times a. Okay, so just put here the value of a and then you will get the length of lattice rectum for the parabola x square equal to minus 16y. So length is equal to 4 times 4, this is equal to 16. Okay, and 16 is basically the coefficient of the linear term. Okay, that means coefficient of y is here 16. So length of lattice rectum is 16 here. You can visualize the figure here. So this is the figure for x square equal to minus 16y. Okay, and from this figure you can easily find focus. Okay, focus is basically 0 comma minus 4. Okay, and here the equation of directly is y equal to 4 and length of lattice rectum is 16. Okay, so I hope it is clear to all of you. So students, that's all for today's lecture. So thank you very much to all of you.